So next we're going to take a quick look at a couple problems in 3D. So the idea here would be find the height of a cliff. So here's my h, there to there. And it's hard to see obviously in 2 dimensions, but this triangle would be sort of, this one would be kind of flat on the ground, and this triangle is vertical up the side of the cliff. So imagine this triangle down here is kind of coming out of the page at us. I know it's hard to see, but that's the idea. So the question, of course, is I want to try to find h. I have my primary angle here at 38 degrees, which is good, but I don't have the hypotenuse and I don't have the adjacent. So if it's a right angle, I want to use SOHCAHTOA. So is there a way I can find this side? And I look at this lower triangle and I say, well, I have this 42 degrees, 63. That means I can find that angle. Okay, I know the sum of the angles, right, is 180. So 180, take away those 2 angles, gives me that one. And then I say, oh, maybe I can use the sine law, because if I call this side x, I know x over 42 would be this distance here, that length, over my theta. And then, so that was the sine law. So sine law there would give me x. And then once I know x, that would be the adjacent to this triangle here, opposite adjacent, I would use tan to get through. So again, it's a multi-step question, but we're trying to get our head around this idea of some 3D triangles. Similar idea here, trying to find this h, and again, this is 2 triangles. This triangle is vertical, that one's vertical, and this one's like flat on the ground. Like imagine this is the ground, and this is a corner, maybe a corner of a room or something. Again, it's tricky to see. The idea being find h. Again, try to find the adjacent. I have my 2 angles. I can find my 3rd angle. And then a sine law, say I called that x there, sine law, x over sine this would be that distance over sine that. So again, that's actually another sine law example to allow you to get through. Once you have the x, of course, you're into SOHCAHTOA to solve for h. Opposite adjacent would be tan theta. This one here, this cube question is interesting. In this case, it's find theta, which is this angle here. So you have to imagine sort of a 3-dimensional cube, and the theta is the angle between this red line that's on the bottom and this line that kind of strikes its way through the middle of the cube. So it starts in this corner, and it goes through the cube, and it ends up at that corner up there. So this is like a triangle that's slicing its way through the middle of the cube. So if that's theta, I need to find this side and this side. So one way to do it is, and I have another diagram here, is you can think of different numbers, but we don't care. You can think of this bottom line I'm trying to find is actually the hypotenuse of a flat triangle that's laying flat on the bottom of the cube. So if I took this yellow triangle and kind of looked at it over here, we see, oh yeah, it's a right triangle, that's 6, that's 5, I can use Pythagorean theorem. I can find out that distance down there pretty easily. In this case, it's 7.8. Once I have that distance, I'm given this distance down here is 3. These are all 3, because it's a cube. So if that's 7.8, that distance there is 3. So now, okay, on this inner triangle that we were talking about, I have this distance, 7.8. I have that distance, 3. I'm trying to find that theta in there. I can do it. It's a right triangle. That's going to be opposite and adjacent. That's going to be tan. So I'd be able to write, in this case, tan theta, 3 over 7.8, and then just use shift tan on my calculator, and that will give me theta. Okay, just try a few problems on 265.